Hello, am I audible and is my screen visible?
Yes, sir.
Okay. Thank you. Good evening, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Aman Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my seventh live session. Uh, in this live session, I will discuss some questions on week 7 topics. So in week 7, evaluation measures, evaluation metrics, and some ensemble methods were discussed. So I will discuss some questions on these topics. And if you have any questions or queries on any of these topics, you can ask me during the session. So we will start solving some practice problems first. And after that, if you have any questions or queries, you can ask me. So this is the question 1. Sensitivity is same as precision, recall, specificity, none of the above. So the definition of sensitivity is same as one of these 4 options. You can write your answers in the chat. Anantapalli Naga Lakshman Kumar says option B, which is recall. Okay. Anyone else? Ansela VM says option B. Okay. So sensitivity is mathematically is defined as from the confusion matrix. It is defined as TP divided by TP plus Fn. So TP is true positives and Fn is false negatives. So sensitivity is defined as true positives divided by true positives plus false negatives. And this is same as recall is also defined as true positive divided by true positive plus false negatives. So sensitivity definition and recall definitions are same. So sensitivity is same as recall. Similarly, precision is also same as specificity. So question 2. Using the bootstrap approach for sampling, the new dataset will have dash number of original samples on expectation. There are 4 options: 50%, 56.8%, 63.2%, and 73.6%. So if the original dataset contains 100% of the dataset, so if we use bootstrap approach for sampling, in the new dataset, how many of the original samples will remain on expectation? Sweta Lakshmi says 63.2%. Okay. Anyone else? The new dataset will have 63.2% of the original samples on expectation. So how can we calculate that? So if let's consider there are n training samples. Uh, if there are n training samples, and bootstrap sampling is sampling with replacement. So if we sample one data point from the dataset containing n elements, the probability that a certain element will be picked is 1 divided by n in each sampling event. 1 by n is the probability for a certain data point to be picked, and the probability of not getting picked for that element is 1 minus 1 by n. And this process of sampling data points is repeated for n times to sample n number of data points. So the probability that a certain data point is not picked uh, throughout the process of n repetitions is 1 minus 1 by n whole to the power n. So this is the probability that a certain element will not be picked over n sampling events. So this is, if this is the probability that the element will not be picked at all over n trials, so the probability of being picked at any at least once is 1 minus this whole probability. So this is the probability that the element will be picked, and it will give us the expectation value for the uh, number of elements that will be present in the new dataset. And now we have to uh, estimate this 1 minus 1 by n whole to the power n. So this uh, if we use limit for a large data set n tends to infinity, 1 minus 1 by n whole to the power n. So uh, it will come out as e inverse, so 1 by e. So overall the probability would be 1 minus 1 by e, and it is same as 63.2 divided by 100, so it is close to this number. So this would be
So,
the,
sir, after applying the limit as infinity, we are getting e power minus 1, sir.
yeah, so only for this part we have to use n tends to infinity for large data sets. So after that, if we apply this n tends to infinity limit, we will get this 1 by e. So overall probability would be 1 minus 1 by e. Is there any doubt in this question?
No, sir.
So C is the correct answer. Question 3. So suppose you have run AdaBoost on a training set for 3 boosting iterations. So if in AdaBoost if we run it for 3 boosting iterations, we will end up with 3 classifiers. So the results are classifiers H1, H2 and H3 with coefficients alpha 1 equals to 0.2, alpha 2 equals to minus 0.3 and alpha 3 equals to minus 0.2. So alpha 1 coefficient is associated with H1 classifier. Similarly, alpha 2 is associated with H2 and alpha 3 is associated with H3. For a given test input X, you want to find out, you find that the classifier results are h1x equals 1, h2x equals 1, h3x equals minus 1. So what is the class returned by the final AdaBoost ensemble classifier capital H on the test samples? So these are the individual results of the or output of the individual classifiers h1, h2, h3 on the test input X. Now in AdaBoost, finally you have to combine the outputs of all the classifiers to find out the output of the to get the final output, and the final classifier is capital H. So what will be the output of the final classifier capital H on this same test example X? with the X misses option B, which is -1. Okay.
So sir is not getting a voice.
No, no, I
You're
have
not with.
already, yeah, I've already explained this question, so I'm waiting for the for all the participants to compute the answer and write. So that's why you are not getting any voice.
Okay, okay.
Okay, so for this question, the final classifier, Adabus classifier H for output of this final classifier H on a test example X is computed as the sine of summation over alpha I hi of x. So this alpha I values are the coefficients values. So alpha I is the coefficient for the ith classifier hi. So alpha I values are given for the three classifiers, and this hi is the output of the ith classifier on the test example x. So these are written here: h1x is 1, h2x is 1, h3x is -1. So this is um, the output of the final classifier h on the test example x. So if we calculate this, so hx would be sine of alpha 1 h1x plus alpha 2 h2x plus alpha 3 h3 of x. So that would be sine of alpha 1 is given as 0.2 and h1x is 1 plus alpha 2 is minus 0.3 and h2 is h2x is 1 plus alpha 3 is 0.2 into this is minus h3x is -1. So there will be sine of 0.2 minus 0.3, so it should be minus plus 0.2, so there would be sine of 0.1. So 0.1 sine of 0.1 basically means whether it is greater than 0 or less than 0. So 0.1 is certainly greater than 0, so class would be plus 1 or 1. So hx would be 1. The final output would be 1 for this Adabus classifier. So different
So
individual classifiers.
what will be the answer if it sums to 0?
If it is 0, then yeah, it is ambiguous in that case. In that case, I think you can consider it as 1. If it is written that you may consider it, if it is greater than equals to 0, then positive plus, less than 0, then negative plus, then it would be 1. But otherwise it might be ambiguous in this case. Yeah. But in such questions you will most certainly get either positive answers or negative answers, not 0 most of the cases.
Sir, the last step, how should we calculate, sir?
Last step means which one?
So the sine of 0.1.
Sine of 0.1 basically whether it is positive or negative, that number is, whether it is greater than 0 or less than 0, because
Yes,
there
sir.
are only two classes, 1 minus 1. So it basically is that. I mean, a similar thing happens in case of perceptron also. Perceptron classifiers. If the output is positive, then you consider it as class 1, and output is less than 0 or less than equals to 0, you consider it as 0. Here the classes are plus 1 and minus 1, so sine of this 0.1. Divakar Tiwari is asking which assignment. This is for week 7 topics and week 7 assignment. Question 4. Uh, Given the following information, so this is a confusion matrix given with actual positive, actual negative columns and predicted positive, predicted negative rows. What is the precision and recall of this confusion matrix?
Once explain the formula, sir.
The formulas, precision is given by true positive divided by true positive plus false negatives, and recall is defined, sorry, true positive plus false positive, and recall is defined as true positive divided by true positive plus false negative. So from this table you have to find out what are the values of this true positive, false negative, so that you can put these values into these expressions to find out the answers. So these formulas have been taught in Week 7 topics, right?
So actually, we know the formula, sir. Please, explain the how.
Yeah, that I will certainly explain. First, let some of the others to calculate the answers, then I will
Sir, I'm
always
not asking about the answer, sir. Explain about this precision and recall, sir.
what is precision and what is recall.
Yes, sir.
So precision basically means that uh, out of all the positive points that your model has predicted, how many are actually positive. So there are two classes, positive and negative, and so it basically says out of all the positive points that your model has predicted, how many are actually positive. uh, and in case of recall, it is out of all the actually positive points, how many positive points that your model has found out.
Okay, sir.
Sweta Lakshmi says option D. Anagha Chogaon says option D. Ansila says 0.4375 precision, recall 0.7. Okay. So from this table, first we need to find out the values of true positives, false positives, and false negatives. So true positives basically means uh, those points are actually positive and predicted as positive by the model. So actually positive and predicted as positive. So this is the shell that represents the value for true positive. And now next thing is false positive. So false positive is uh, not actually positive but falsely predicted as positive. So they are actually negatives but predicted as positives. So they are predicted positive but they are not actually positive. Now false negatives, so they are not negatives but predicted as negatives. So they are actually positive but predicted as negatives. Similarly, the other cell would be true negative. So this cell is true negative, but that true negative does not appear in any of the expressions for precision and recall. So that will not be used. So this TP or true positive is 35, false positive is 15, false negative is 45. Now we can find out precision. Precision is true positive divided by true positive plus false positive, which is 15. So there will be 35 divided by 50. So it would be 0.7, and recall would be true positive divided by true positive plus false negative. False negative is 45. So total 35 divided by 80, we should be around 0.4375. So precision would be 0.7 and recall would be 0.4375. So that is option D. So in such questions, you will be given a confusion matrix with actual positive, actual negative, predicted positive, predicted negative values. So from that table, you have to first find out what are the values of true positive, false negatives, and then you have to use these two formulas to find out the values of precision and recall. So precision is 0.3, recall is 0.4375. Now question 5. Suppose you have 10,000 emails in your mailbox, out of which 200 are spams. The spam detection system detects 150 mails as spams, out of which 50 are actually spams. What is the precision and recall of your spam detection system? And Nishkars Verma says C. Okay. Muthukumaran Iyer says option C. So for this question again, you have to uh, uh, find out the values of this true positive and false positive and true positive and false negatives for recall. So precision is true positive divided by true positive plus false positives. Recall is true positive divided by true positive plus false negatives. So from this question you have to find out the values of TP, FP and FN. So TP is true positives. That basically means those points are actually positive and also predicted by positive. Predicted as positive by the spam detection system. So it says that the question says that the spam detection system detects 150 mails as spams, out of which 50 are actually spams. So these 50 emails are actually spam and they are also predicted as spam. So this TP is 50. Now false positive is those points are not positives but predicted as positives. So again in the second sentence it says that the spam detection system detects 150 mails as spams, out of which 50 are actually spams. So basically means 50 are actually spams out of 150. So 100 emails were not spams but detected as spams. So those are false positives. So those are not actually positives but predicted as positives by the model spam detection system. So FP is 100, and finally the value of Fn for the recall expression. So Fn is those points are not negatives but predicted as negatives. So the first sentence says that out of 10,000 emails in the mailbox, 200 are spams. So 200 are actually spam emails, but the spam detection system detects only 50 of them as spams. So 150 actually spam emails are not detected as spams. So 150 data points are not negatives, but they are detected as negatives. So Fn is 150. Now you have to put these values into the two expressions, 50 divided by 50 plus 100 and 50 divided by 50 plus 150. So there will be 50 divided by 150, which is 33.3%, and it is 50 divided by 200, which is 25%. So 33.3% and 25%. So that is option A. Yes, so option A is the correct answer. So false negatives is that here negative basically means uh, positive is the spam class, negative is the non-spam class or the genuine emails. Those are not spams. So negative means those points are not negatives but predicted as negatives. They are the spams but predicted as non-spams. So total 200 emails are spams, but the model detects only 50 of those actual spam emails as spams. So 200 minus 50, 150 emails are spams but not detected as spams. They are not negatives but detected as negatives. Though negative basically means non-spams. So those 150 emails are not spams. Sorry, 150 emails are negatives but not detected as negatives. They are so that's why they are false negatives, falsely classified as negatives. Now question 6. What is the effect of using bagging on weak classifiers for variance? What will happen to the variance of the classifier if we use bagging on weak classifiers? So option A says increases variance, option B says reduces variance, option C says does not change. Shweta Lakshmi says option A, Arundhati Das says option B, Muthukumaran Iyer says option A. Anyone else? Nishkarsh Verma says option B, Anaga Chowgankar says option B. The correct answer is option B, that it reduces variance. So if we make an ensemble classifier using bagging on weak classifiers, the variance of the final resulting classifier would be lesser than the variance of the weak classifiers. So that is one of the advantages of bagging and of most of the ensemble algorithms. It reduces the variance. Now question 7. You are building a model to detect cancer. Which metric will you prefer for evaluating your model? Accuracy, sensitivity, specificity, MSE or mean squared error. Sensitivity is basically recall and specificity is precision. So which evaluation metric should you prefer for evaluating a cancer detection model?
Precision.
Okay. Tukuman Nair is option D or this is option C. So the correct answer here is sensitivity or recall. So recall is preferred mm, when you are evaluating a model such as cancer detection model where the positives are very low in numbers, because in cancer detection model most of the samples would be negative, basically non-cancer data points, and very few points would be positives, which are cancerous data points. So in such cases, the definition of recall is that plus TP divided TP plus Fn. So it is basically out of all the uh, positive points, how many points are being detected by your model. This denominator TP plus Fn is simply says how many points are actually positive, total number of positive points in the dataset. And so recall basically says that out of all the positive points, how many your model is able to detect. So out of all the cancerous data points, how many cancerous data points your model is able to detect. So that is what recall is doing here, and we want to maximize that, and we don't want to simply maximize accuracy because there will be very few uh, points with cancer. So even if your model is not that good, if it even if it predicts all points as non-cancer, it would still get a very high accuracy. So accuracy should not be the measure that you should use, because the class distribution is very skewed here. There are very few points which are positive and most of the points are negative here in this data set. So that is why recall is preferred, that out of all the positive points, which will be very few because very few points are cancerous points, Out of the all positive points, how many positive points your model is able to correctly classify. So that is why we prefer recall in such problems. Is there any doubt in this question?
Hello.
Yes.
In which cases generally you will prefer precision then?
So in some of the cases where so precision is given by Tp divided by Tp plus Fp. So basically the denominator says that let me write it properly. The denominator Tp plus Fp is basically how many positive points, how many points are labeled as positive by your model, and out of them how many you are trying to your model has correctly classified as positive. So if your model is trying to maximize false positives, in that case this precision can be used. In many of the cases where the data points are not such skewed, here there are very few positives, most of the points are negatives, and in many cases this would not be the case, that there will be very few positives. In such cases precision might be preferred. So it basically depends on the task and the problem, very much specific to the task and the problem and the data set also. What is the distribution of the classes in that data set? So for now I'm not able to remember any specific data set, but in many data sets where such class distribution is not so much skewed, in those cases precision can be used. And also in those some cases accuracy would be used, because accuracy is one of the most fundamental evaluation metrics. Question 8. Consider building a spam filter for distinguishing between genuine emails and unwanted spam emails, assuming spam to be the positive class. Which among the following would be more important to optimize? Precision and recall. So between precision and recall, which evaluation metrics should you consider in case of building a spam filter? Obviously accuracy can be one of them, but out of precision and recall, which one should you prefer?
precision,
Precision, okay. Muthu Kumaran IAS is precision. Arundhati Das says option B, which is recall. Niskarsh Varma says precision. So in spam detection system or spam filtering system, we don't want genuine emails to be wrongly classified as spam emails. So this is one of the most basic requirements in spam filtering systems, that we don't want genuine emails to be labeled as spam emails. But even if we have some of the spam emails labeled as genuine emails, that is fine, but we don't want actual genuine emails to be labeled as spam emails. Then we will not be able to uh, see those emails. So that's why we don't want actual genuine emails to be termed as labeled as spam emails. So in such cases we should prefer precision, because precision is, out of all the positive, here spam is the positive class. So out of all the positive points, out of all the spam emails, how many your model is able to detect? So precision would be able to find out that precision will not, if we optimize precision, it will not mark genuine emails as spams. It will try to minimize that number, so that this TP by TP plus FP, which is this denominator, is basically total number of positives. So it will try to find out most of the positive, correctly, it will try to correctly classify most of the positive points, says positive is spams. But if we use recall, so recall would try to, recall is TP divided by TP plus FN. So sorry, it is not P. So the denominator in precision, denominator is precision is TP by TP plus FP, which is the denominator is the all the positively classified data points, the data points which are positively classified by the model. So if we optimize precision, it will try to correctly classify most of the spam emails. So it will most likely not mark the genuine emails as spam emails, otherwise the precision value would drop. But in case of recall, it is simply out of all the positive points, how many your model is able to correctly classify as positives. So if we maximize recall, we will have some of the genuine emails being classified as spam to increase the value of the recall. So both the measures have some drawbacks and some advantages, but if we still consider the basic requirement that genuine emails should not be classified as spam emails, precision would achieve that in most of the cases. So precision would try to minimize the number of genuine emails being labeled as spam emails. So that's why in this case we would prefer precision. So if we optimize recall, we may be able to capture more spam emails, but in the process we may also increase the number of genuine emails being predicted as spams. Because if we try to maximize recall, it will try to mark most of the emails as spams. So in that case, some of the genuine emails will also be predicted as spams. On the other hand, if we optimize precision, we may not be able to capture as many spam emails as in the previous approach, but the percentage of emails being classified as spam, actually being spam, will be high. So there is a trade-off. Both the methods, both the metrics have some advantages and disadvantages, but still we want that genuine emails should not be predicted as spam emails, which can be obtained by optimizing precision. So that's why precision should be preferred in this case. Is there any doubt on this question? Now question 6, regarding bias and variance, which of the following statements are true? Models which overfit have a high bias, models which overfit have a low bias, models which underfit have a high variance, models which underfit have a low variance. So multiple options may be correct in this question.
B. One is B.
Okay. Utpon ISSCB, Anaga Choga versus
C.
BD,
B, C. B and C.
Arundhati Das says BD, Ansel again says BD.
No. BD. Sorry, BD.
Yeah, you can write your answers in the chat.
BD.
So overfitting is associated with low bias and high variance. So overfitted models generally have low bias, but variance would be high in case of overfitted models. Um, on the other hand, for underfitted models, bias would be high, but variance would be low.
No.
So overfitting models which overfit have a low bias, and models which underfit have a low variance. So these are the two correct options, B and D. Question 10. Considering the AdaBoost algorithm, which among the following statements are false? So more than one option may be correct in this question. In each stage, we try to train a classifier which makes accurate predictions on any subset of data points where the subset size is at least half the size of the dataset. Option B says in each stage we try to train a classifier which makes accurate predictions on a set of data points where subset contains more of the data points which were misclassified in earlier stage. Option C says the weight assigned to an individual classifier depends upon the number of data points correctly classified by the classifier. And option D says the weight assigned to an individual classifier depends upon the weighted sum of the sum error of the misclassified points for that classifier. So more than one
One
option may be
option
correct.
D. One option is D.
Anagha Chogun versus BD, Arundhati Das says BD, Ansila VM says BD, Anantapalli Naga Lakshman Kumar says BD. Okay. Yes, you have to find out the statements which are false. Okay, these were for question 9. Okay, okay. Oh, question 9 also had B and D. Yeah. Okay, then okay. Arundhati Das's AD.
B is false.
Okay. More than one option will be correct in this question. So if we go through each of the options, so the first option says that in each stage we try to train a classifier which makes accurate predictions on any subset of data points where the subset size is at least half the size of the dataset. This is certainly not correct. We simply don't pick half of the dataset and try to predict accurate predictions on those data points. So this is not correct. Uh, Option B says in each stage we try to train a classifier which makes accurate predictions on a subset of data points where the subset contains more of the data points which were misclassified in the earlier stage. So this is correct regarding AdaBoost. that we try to retain most of those points which were misclassified in the earlier iteration. Option C says the weight assigned to an individual classifier depends upon the number of data points correctly classified by the classifier, which is not completely correct, because option D is actually correct, that the weight assigned to an individual classifier depends upon the weighted sum error of the misclassified points for that classifier. This is actually correct. So the weight of an individual classifier depends on the weighted sum of the misclassified points, not exactly on the number of data points which are correctly or incorrectly classified by the classifiers. It also depends on the uh, weights for those points. So regarding AdaBoost, option B and D are the two correct statements, but you have to find out the statements which are false. So false statements are A and C. So false statements are A and C. So these are the two correct answers in this question. So the weight assigned does not directly depend on the number of data points correctly classified, or even the number of data points which are incorrectly classified by the classifier, but it also depends on the weights. So weighted sum error of the misclassified points. Question 11. You have a dataset with 1000 samples and 5 classes for classification. What would be the training size for a 20-fold cross-validation? So what is the size of the training dataset if we use 20-fold cross-validation on this dataset? Arundhati Das says option D 950. Okay. Anyone else? The correct answer would be option D 950. So if you have 1000 training samples, and it does not depend on the number of classes, so this information is not really required for this question, but you need to know how many folds you would use. So the value of k is 20 here for k fold cross validation. So 1000 data points divided by value of k, which is 20, so each fold would contain 50 data points. In k-fold cross-validation, k minus 1 folds are used for training, and one fold, the final fold, used for validation. So k minus 1 fold is used for training, and the final fold, only one fold used for validation. So the size of the validation would be obviously 50. One fold contains 50 data points. So the remaining 19 folds would contain 950 data points. So 950 is the size of the training data set. So this number of classes is not required, but value of k for k-fold cross validation is required. Question 12. Which of the following are true? So this TP is true positive, TN is true negative, FN is false positive, FP is false positive, FN is false negative. So precision, recall, accuracy, and also there are two expressions for recall. So more than one option may be correct in this question.
1 and 2, A and B.
Okay. Niskars Verma says AB. Arundhati Das says AB. So correct answers A and B. Precision expression is correct, TP by TP plus FP. Recall expression is also correct, TP by TP plus FN. Accuracy expression is not correct, and the recall expression, this one is not correct. So correct answers are A and B. Yeah, so these were the questions that I wanted to discuss in today's live session. Now if you have any other questions or queries, you can ask me.
Excuse me, sir.
Yes.
I have one doubt actually regarding previous year question of assignment 1. And the question is like this: consider a binary classifier problem where we are given certain measurements from a blood test and need to predict whether the patient does not have a particular disease, class 0 or class 1. And in this problem, the false negative predicting that the patient is healthy and more serious as compared to the false positive. Which of the following is an appropriate cost matrix? So what is the difference between cost matrix and this?
The cost metric, what were the options? Cost metric basically means the objective function or the cost function that you should use.
So, for example, we prepare a paper, confusion matrix जो हम prepare करते हैं, two positive, two negative या predicted और actual में करते हैं. So the row denotes true class and the column denotes predicted class, and there are 5
Yes.
options given.
Yes. Yeah, this is how the confusion matrix is written.
Yeah, this is how the confusion matrix is created, but it is asking about cost matrix, and the options are quite confusing. So
Confusing means what were the options?
the options are the matrix first cost matrix is given 0, 100, 0, 0.
Okay,
Like
such
this.
confusion matrices are given. Confusion matrices are
Yes,
given.
matrices are given 0, 100, 1, 0.
Okay, it would be difficult to find out the answer without looking at those.
Yeah.
Yeah. So if you can post this question in the discussion forum, I will check the discussion forum and answer there.
Okay, sir, I will try to
Yeah,
clear it out.
just post it in the discussion forum. I will check it
But it
and.
is not given there कि वो जो predicted value है मतलब मैट्रिक्स कैसा बना हुआ है वो क्लियर नहीं है. तो कंडीशन कॉस्ट मैट्रिक्स की ये होती है कि फॉल्स नेगेटिव शुड बी ग्रेटर देन फॉल्स पॉजिटिव, तो वो ग्रेटर वैल्यू जो डायगोनल वैल्यू आ रही है दैट इज क्वाइट कंफ्यूजिंग.
Yeah, it would be difficult without seeing those confusion matrix options. So you can post in the discussion forum. I will check the question and let you know in the discussion forum.
Okay, fine, sir, thank you. Okay, thank you.
Okay.
Sir, when is the next class?
Can you repeat your question?
When is the next class? Next class time slot.
Next class, my live session would again be on next Monday from 6 p.m.
Okay.
discuss what is the expression for accuracy. So accuracy can be represented if we have this uh, confusion matrix. It is TP divided by TP FP FN TN. If I am not wrong, this is the confusion matrix. So in that case, accuracy is TP plus TN divided by sum of all four, TP, FP, FN, TN. So because these two rows, TP and TN, these two rows are the correctly classified points. These two cells, TP and TN. So these two would be added up, TP plus TN. This is the number of data points which are correctly classified, irrespective of whether those points are positives or negatives. And the denominator, in the denominator, we are simply adding up all the different components in the confusion matrix. That basically means all the data points present in the test set. So all the correctly classified points divided by total number of points. So that would be your accuracy. Arundhati Das's explain 7, 8. So in 7, we are building a cancer detection model. So, so in cancer detection model, we want that most of the cancerous data points should be detected as cancers. Cancer represents positive plus here. So most of the positive data points should be detected as positive. And if we see the definition of recall, it is simply TP by TP plus FN, which is simply total number of positive points. So it is the fraction of correctly classified positive points. So if we maximize this sensitivity, we basically the model would be able to find out most of the cancerous points correctly. But if we simply maximize the accuracy, that would not be good enough because most of the data points are already non-cancerous. So even if the model predicts all the data points as non-cancer, it will still have a high. It will still have a high accuracy value. But in recall, that would not happen. Because if it is able to predict the cancerous data points as cancers, then only it would have a high recall value.
Okay, so in this cancer detection model, here false negative is what? All those cells which are actually cancerous, but it has been predicted as non-cancerous, right?
Yes,
And that
yes.
is a very dangerous thing. So we should not, we should try to minimize FN, right?
Yeah, we should try to minimize the false negatives here.
False negative. So if we try to maximize recall, then the TP will be maximized in the numerator, and
Yes.
hence FN will be reduced in denominator. Is it like that?
Yeah, you can explain it like that, but the denominator itself as a whole is basically total number of positive points. If you don't break it up as TP plus FN,
Hmm. Hmm.
it is simply the total number of positive points in the dataset.
Hmm.
So out of all the cancerous data points, how many are correctly classified as cancerous by your model? That is simply recall. You can also explain it as TP plus FN, but it is easier to simply denote the denominator as P in this example. P is total number of cancerous data points here. So if we are able to find out most of the cancerous data points out of all the cancer data points, that is our goal.
Okay, and like relating to this cancer detection model, like if we consider COVID also, suppose some COVID detection model is
Yes.
there, and there also we should, like if somebody is having COVID, we should detect he is
Yes,
having
yes,
COVID.
yeah. In
If
most of
somebody is
these,
having
yeah, in
COVID,
most of these diseases where there are very few positive points, and in most of the such diseases which are rare, The positive points will be very low, negative points will be very high, whether it's COVID, whether it's cancer, and there are many more such mortal diseases. But the positive points should be low and negative points should be high. In such cases, recall is much more important than the other matrices.
Mm. And similarly for question number 8, where our goal
Yeah.
will be that genuine emails should not come as spam, right?
Spam, yes,
So,
yes.
so here for precision, in precision denominator is having FP, false positive.
Mm.
So that means like actually it is a genuine email, but got predicted as spam. So that
Yes,
I should try to reduce in the denominator,
yes.
so that in the like total and in the numerator that value will be maximized, right?
Yeah, yeah, yes, that is true. The precision enforces that you don't mark most of the genuine emails as spams. But if
Mm.
you optimize recall, it will predict most of the emails as spam emails. Even in that case, recall would be 100%. If you
Mm.
simply predict all the emails as spam emails, but that is really bad. That should not happen. So
Okay.
that's why precision is preferred here.
Okay. Now just one again small question. Like for the cancer detection, accuracy will not help, right?
No, accuracy will not help here.
And also for this email spam detection, accuracy will not help.
Yeah, here accuracy will not be that helpful, but
Mm.
you may still use accuracy. Here question is out of these two, which should be
Mm.
preferred? Here accuracy is still can be used, but it would still be very much skewed towards 100% because most of the emails are non-spam. So in
Mm.
any task where there are very few positive points and most of the points are negative, or even in the other case, very few negatives and most of the points are positive. That is, the class distribution is skewed. Accuracy would not help. In those cases, precision, recall, F1 score, these metrics are much more useful.
F1 score, what is the physical significance of F1 score? Like
F1 score,
when
there is no, I
uh,
mean, I don't remember any physical significance, but it simply combines precision and recall. So 2p r
yes,
divided by p plus r. So precision and recall both are trying to both are evaluation matrices, but so metrics. So it tries to combine both the evaluation metrics together.
okay. So F1 score, behavior of F1 score will it be similar like accuracy metric only?
No, accuracy. In accuracy, we don't think about precision and recall separately at all. It's
Mm.
comes up all the data points uh, into one because the numerator is total number of correctly classified points divided by total number of points. So it does not take care of precision and recall separately. But in F1 score, it combines the precision and recall value so that if you maximize F1, both precision and recall will be maximized. Still, there will be a
Yes.
trade-off, but both the matrices are maximized to some extent. Both precision and recall are maximized. But in accuracy, it does not happen. Accuracy in the cancer detection system, it would get 99.99% even if you predict all the data points as well, negatives.
Correct. Okay. Thank you so much. Thank you so much.
Okay. Can you share previous class? So all the class notes are already shared through Google Drive, and you have a uh, tab in the course homepage named as problem solving sessions. There you will get all the links of these video lectures as well as these presentations. So if there are no other questions or queries, we can end this session now. Thank you everyone for joining. We will meet again next week.
Thank you, sir.
So not exactly through Google Drive, but the links are there. You can in the course homepage you can find out one tab called problem solving sessions. So there you will find all these links of these video lectures which are uploaded in YouTube, and all these links to these class notes which are uploaded in Google Drives. A discussion forum in the course homepage, you have on the top you have something like question answer or ask something, something is written there. In the course homepage there is on the top it is written somewhere Q&A or question and answer, something is written there, so through that you can go to the discussion forum. That is a Google groups discussion forum. Okay, thank you everyone.